Hey folks, it's Andrew Kilpatrick here, and today I'd like to show you my pick and place machine. And more than just the machine, I'd like to show you the whole surface mount assembly line setup. I've got a lot of questions from people since I've had this set up, and I thought I would give sort of a close-up walkthrough the entire process and show how it works and give my thoughts and comments on the equipment that I ended up getting, and I'll show you all the details. So the machine we have is called the Neoden 4 from Neodentech. They're a Chinese company and they've been making pick and place machines for a while, but this was the first one that looked sort of real enough that I would trust it in my shop. I was originally put off by their weird demo video, which clearly has a speech synthesizer and another guy lip syncing along with it, and then also reading a Chinese sort of English script, which was really bizarre. But anyway, after talking with the people at Neodentech, it became clear that they are actually legit and know what they're doing. They've been really good with support, and they answered all my questions via email. So overall, it's a pretty good product for the price. So the first step to running a pick and place job, obviously, is to have some information loaded into the machine as to what it should do. So in this case, you basically need information from your PCB design file. There's a standard file format, some people call it a centroid file, which basically has the list of parts and their rotations and offsets from the edge, the corner of the board, and so on. You also need to know information about the parts and how they're loaded into the various feeders, the rotation of each component, and what feeder it's in, and how much it should advance after each component is picked up, and so on. So the end goal is to have a file that can be loaded onto the actual pick and place machine, and this file has to contain all the information about the feeders and the settings for each feeder, as well as the list of parts that actually get placed on the board. Okay, so surface mount assembly basically consists of three major steps. So the first step is the paste application step. In big machines, big setups, they usually have an automated machine that does this. So the board would go in, and then the solder paste is applied, and then it would go on to the pick and place machine itself. And usually that happens automatically. Now, in a small setup, usually that's not practical or cost effective to do that. So what we use is you just use a stencil, same as the stencil in a big machine, except we just do it by hand. So underneath here is basically a jig that you can use to set up the board, and it holds the PCB positioned correctly. And then on the top here are holes where the solder paste goes through, and basically the solder is suspended in a sort of a gooey liquid, and then it goes through the holes and onto the PCB in the correct locations, and those are the places where parts will be placed down. So every terminal on every chip and resistor and capacitor will get some paste applied to it. Okay, so once the paste is applied to the board, then it goes in the actual pick and place machine where the parts get put on. So the boards usually go in here. Sometimes we use a carrier like this, and that sort of helps get things really aligned. The board goes in on this conveyor and is taken into the machine, and then using vacuum suction, it goes and picks up each of the components, checks them with a camera to make sure that they're aligned correctly, and then it puts it on the board. And the fact that there's paste on the board means that the part sits there and doesn't move around or anything. And then once the parts are all put on, then the board comes back out. We just use the front. It doesn't connect to anything else automatically. And then the board goes in the reflow oven, and the reflow oven is the third step to our process. Okay, so the third step is the reflow oven, and this actually makes the solder go molten and gets rid of all the liquid, and when it cools down, the board is essentially soldered. All the surface mount components solder at the exact same time, and then they all cool down and the boards come out of the machine, and then it's all set to go. So I guess in conclusion, the most important question is it worth getting a system like this? Will it save you time and make you money in your small business or as a fairly advanced hobbyist? And is it worth all the trouble of getting it set up and tuned and installed and dealing with it on a regular basis? And I would say that really depends on the quantities that you're making of whatever you're making, the complexity of your boards, and also your workflow and your setup. Do you have time to babysit a machine like this? Because this isn't an automated assembly line. The steps, as you saw, are fairly manual, so you're going to have to spend time dealing with each phase of the process per board or per panel. And so, if you want to just press go and work on something else, that's probably not going to happen with a system like this. But if you have some complicated boards and a number of surface mount components, and you just want to make sure they get installed properly, and don't want to have to send them out and get quotes from a PCB assembler and so on, and wait however long it takes, then this kind of system might be the right thing for you. So for us, we found the challenges really have to do with the accuracy and the pitch of the components. The accuracy of the machine is pretty good. The pitch of the components that you can actually place is much better than the overall system accuracy. And what I mean by that is the stencil printing equipment, this hinged mechanism that I showed you, is really not very accurate. And depending on the paste and depending on the size and sort of shape of your board, you're going to have trouble getting down much lower than, I would say, 0.8 millimeters. You might be able to run some TSOP style of chips, but pretty much anything smaller than that, you're going to have trouble getting the paste printed on accurately enough. Also, the reflow oven that's sold as part of the Neoden kit is totally useless, and please don't buy it. It's totally crap. And you need to get a good oven that has a good reflow profile that's repeatable. Also, you need a vent, either to some sort of an air scrubbing unit, like a fume extracting unit that's made for reflow ovens, or you need to vent to the outside, or both, preferably. And the other thing is that the system isn't really perfect. It does have some limitations. We've had a little bit of problems with the feeders. We had a few that were that just failed partway through a job, and those were replaced by Neoden. They were pretty good about sending us replacements free of charge and everything. But overall, the feeders aren't really that great. The fact that you can't load them outside the machine, you have to load them on the machine, makes it a bit of a challenge. And the other thing is they just make mispicks quite often, especially on really small parts like resistors and caps. So prepare for some scrap. And unfortunately, at least the software I'm running doesn't keep track of any of the scrap items that were used, or wasted. So that's a little bit of a problem, because you can't really estimate how many more components you used on your job because of things like mispicks. So that would be nice if that would be included in the software, but unfortunately that's where we are right now. But overall, I would say, compared to getting quotes, paying for setup fees on programming a job where you can do it yourself, and so on, it's totally worth it. And I would say that if your quantities that you're building of a board are between, let's say, 12 and 100 panels in a sort of typical run, then I'd say this kind of system would be pretty useful. If you want to run it day in and day out doing stuff, I think what you're going to find is that the cost of the labor and all the other sort of niggly details about keeping a machine like this up and running, it's really not set up for sort of heavy-duty operation, I would say. And if you've got quantities like that, you probably have time to wait. And in that case, it's better to probably outsource your job to some place that has slightly cheaper labor, and pay for the shipping, and get the boards done on a big fancy machine, and done by people who know how to solder really well to do the through-hole components. But that's basically my conclusion. You know, for smaller jobs, smaller physically sized boards, and when you just want to make them quickly and not have to deal with a lot of outsourcing and so on, the system's really good. But we don't do all of our jobs on it. We only do the smaller boards that we make for some sorts of assemblies. So you really have to sort of pick and choose whether it will work for you, and you also have to just figure out, you know, which jobs are worth running in-house and which ones are worth sending somewhere else. Anyway, I hope this video was useful, and good luck with your projects.